Okay, here we go. The calculus of inverse trigonometric functions. So maybe remember from before. By the way, you should have out your various calculus notes sheet every day from now to the remainder of the year. Unless you have memorized that sheet entirely, you should have it out in front of you. We have covered this topic before, and we're going to reintroduce it again. The derivative of arc sine, maybe you remember, is 1 over the square root of 1 minus x squared. The derivative of arc cosine is negative 1 over the square root of 1 minus x squared. Without looking at your sheet, does anybody remember what the derivative of arc tan is? 1 over 1 plus x squared. How about the derivative of arc cosecant? Is going to be, I'll do secant first. Secant is 1 over x times the square root of x squared minus 1. Secant inverse, exactly. Yep. And arc cosecant will be negative 1 over x times the square root of x squared minus 1. Arc cotangent is negative 1 over 1 plus x squared. If you were to look on the left side of your various calculus notes sheet, you'd see all those derivatives sitting there right in front of you. All right? So what we're going to do today is we are going to transfer these into integrals. And really there's just 3 integrals we need to keep in mind. These are the 3. If you attach a negative, it just changes a little bit. It's not that big a deal. So what is the antiderivative of 1 over 1 plus x squared? Arctan. So I'll write it as Allison said, inverse of x plus c. What is the integral of 1 over square root of 1 minus x squared? Arc sine. And then the last one. Secant inverse plus a constant. Just put negative over. Okay, so here we go. You already know how to do substitution. I'm just showing you a few more rules that we're going to use at this time. The first thing you need to do is you need to identify which of the forms does this take. Does it take the form of tangent inverse, sine inverse, or secant inverse? What do you think? It does take the form of sine inverse. Why sine and not secant? There isn't any variable out front at the bottom, so that's probably our best indication. Okay. Not always. There are some tricks, but we're not going to get into the real difficult examples. So what I want to do is I want to come up with this. I want to come up with 1 over u times the square root of u squared minus 1. Oh, I'm sorry. I just told exactly what I wasn't supposed to do. I was paying attention to that. That's what I want. In order to create that, I need to get a 1. Right now, instead of a 1, what do I have? I have an 8x. That I can work with. It's this 1 right here that I'm really concerned about, the 1 underneath the square root. I have a 9 instead. We got an idea of what I can do to get rid of that. Multiply is an option. I'm going to say it differently. I'm going to factor something out. What do you can factor out at the bottom? That would create a 1. A 9. And so as I write this, I'm going to raise the integral of 8x over the square root of 9 times. If I factor out a 9, what am I left with? Write it as 16 16 over 9 x to the fourth. Okay, I got that. I need this 1. Now I have a 1. I'm going to bring, yes. This 9, I'm going to bring it outside the square root. What would it become? Become a 3. I'm really close. I need something squared. Right now I have 16 over 9 x to the fourth. What is something you would square to get 16 over 9 x to the fourth? 4 over 3x squared. I'm going to write that as being squared. See how this now fits this form quite nice? I have a 1 minus something squared. That something that I'm squaring is my u value. So u is equal to 4 over 3x squared. No. So what is du? 8 over 3 x dx. Do I have an 8 over 3x dx? Isn't that nice? All of this gets replaced by what? Du. So now you have the integral of 1 over the square root of 1 minus u squared du. What is the antiderivative of 1 over 1 minus the square root of 1 minus the square root of 2? Sine inverse. So we get sine inverse of u, and u is the goal here is that if I wrote this on the board, would you be able to do that using substitution? Hopefully there comes a point where we can do all substitution type problems together, and that's going to be the goal of your final exam. That's what we're going to be preparing for. Okay, let's try another basic example, number 2. Which form does this fit? Secant inverse. So we want this to be of the form 1 over u times the square root of u squared minus 1 du. What is the first thing I should probably focus on trying to achieve? Yep, I need that 1 on the top. I also need that 1 on the bottom. I've got that 1. So that's kind of helpful. I don't have to factor anything out to make that a 1. It's already there. So I need something squared. What would you square to get x to the 6th? X to the 3rd. So I'll rewrite this as 3x squared over x to the 3rd times the square root of x to the 3rd squared minus 1 dx. This is extremely important that you pay attention to this next step. What is u? Look at this. U is x to the 3rd. Do you have the same thing sitting there? If you didn't, you'd have to play around to come up with a constant to make sure it worked out. Say, for example, this was a 2 in the denominator here, 2x to the 3rd. Well, that's not sufficient. You'd have to get rid of that 2 sitting there. Okay? All right? I thought you were going to say something. You're just expressing distaste. Got it. Okay, so I have u is equal to x to the third, so du is equal to 3x squared dx. You have a 3x squared dx. You do. So this will get replaced by du. This will be u, and that will be u squared. So we now have the integral of 1 over u times the square root of u squared minus 1 du. What is that antiderivative? Secant inverse of u, which is x to the third plus a constant. Thank you for looking at the glass as half full. So far, the two problems have worked out very nicely where we haven't had to play around to come up with a constant that's not there. See if these other follow suit or not. Which form do you think that this will fit? Sine inverse. So we are looking for an integral of 1 over the square root of 1 minus u squared du. You've now seen a couple examples. What do you think my first step should be? Get the 1. How will I get the 1? Factor out a 25. When I factor a 25 out of the square root, it will become a in the denominator. So I now have the integral of 20 x to the third over 5 times the square root of 1 minus x to the 8th dx. Great, I've got the 1 minus. Now I need something squared. What is that something squared? So I have the integral of 20x to the third over 5 times the square root of 1 minus x to the fourth, that quantity squared dx. What is u? What is du? Do you have a 4x cubed dx? Yeah, you have like 20 and a third over 5. No, um, this whole piece will just be replaced by du. We now have the integral of 1 over the square root of 1 minus u squared du. That antiderivative gives us sine inverse of u, which is exactly. Anytime you don't have boundary conditions, you want to see. We've got 1 more minute to lunch. Which form do you think this will take? So we're looking for 1 over 1 plus u squared du, because you're right, it will take the form of u. I need to come up with a 1 in the denominator, so what should I do? Factor out a 16. I now need something squared. What is that something squared? What is u? Du is that is not what we have, and so we'll pick up with that when we come back. I buy more than the store. mattress, I'll have an apple. All right, so here we go. We can see that u is equal to 5 over 4x squared, so du is 5 over 2x dx. You have a 5 over, excuse me, 5 over 2x dx. You don't. So what do I do? Okay, I need a 10 on the top, so I'll multiply by 2 on the top, and I need a 60 on the bottom, so 8 on the bottom. 2 eighths or 1/4. Okay, so 1/4 du will be equal to 5 over 8 x dx. We have 5 over 8 x dx. Yeah, we do. This is 5 over 8 x dx right there. So we then have the 1/4 times the integral of 1 over 1 plus u squared du, which is arctan 1/4 arctan of 5 over 4 x squared plus c. Number 9 looks pretty confusing, doesn't it? I'm sorry, number 5. What form are you thinking? Arc sine is correct. Is it going to take on the form of arc sine because we have the square root? We have a squared, we don't have any variable on the outside. So I'm going to start by factoring out a what? A 9. So I have the integral of -4 sine of 4x over, if I factor out a 9, what is outside the square root sign? 3. What? Oh, okay, I've got it. I've got it. Now I understand what you're saying. The question is, we're using the form arc sine. Why not use arc cosine since you see a negative sign? Don't worry about that. Just if it's a negative, attach the negative if the sign inverse of u. You can always change it afterwards. Because they're different. One's positive, one's negative. But that's why I only wrote these 3 down, because these are primarily used as the forms. Yes. If you chose to write it as arc cosine, I would give you credit. But arc sine is just fine. I would. Okay. So I factor out the 9, and I get 1 minus 1/9 cosine squared of 4x. So the 1 is taken care of. Now what I need is I need something squared. So I have -4 sine of 4x over 3 roots of, what do you square to get 1/9 cosine squared of 4x? Yep, or 1 over 3 cosine of 4x, that quantity squared. So this is now of the form 1 over the square root of 1 minus u squared du. Because we have a 1 and we have something squared. So let's try to figure out the rest. What is u in this scenario? 1/3 cosine of 4x. If I take the derivative, what rule do I have to use? The chain rule. Derivative of the inside thirds. Derivative of the outside, negative sign. Negative. So we did come up with the negative. Okay, so we're not going to have to use that part cosine. Yes. Factored out a 9. What's the square root of 9? Okay, so we've got this. Do you have a negative 4/3 sine of 4x dx? Yeah, you do. So all you need to do is just write as the integral of 1 over very good. And what's the antiderivative of? And what is u? Well, I think that's kind of an impressive answer. Hopefully you feel the same way. Okay, last one. Which of the 3 forms does this take on? Tangent. Or tangent inverse or arctangent. So, what am I going to factor out of the bottom? 9. The integral of 10 is the fourth over 9 times 1 plus 4 over 9 x to the 10. What am I squaring? This has the form I want. What is u? Du is multiplied by 1/3. Was that an antiderivative? Yep. Well, I, yes and no. I have a general idea that that's where it's going to end up. But as I look at this from the very beginning, or as I look at this from this point right here, 10 over 9 x to the 4th dx, that is all taken care of by du. Right? So I got 1 du and the 1/3, right? So in the denominator, I have that 1. And this, that goes in the. So I'm taking all of this and using it to create that integral. I just have a really good idea at the beginning that that's what I'm working with. All right, so I got a worksheet for you.